and changing these ecosystems. And his work, again, is really at the forefront of sort of our current understanding and how to cope with these systems and conserve them.
Thanks, Jake. So I realize Michigan's a long way away from the nearest coral reef, but I view reefs as sort of a lens through which to view human-environment interactions, and I hope that the approaches that I talk about today and the sort of general lessons to take home from today aren't really about coral reefs, but you can think about ways that they might be applicable in agroecosystems or montane systems, temperate forests, or whatever. So hopefully what I'll be talking about is more social ecological dynamics rather than reef-specific things. So scientists often spend their careers looking at averages or trends, and this is incredibly important for discerning the signal from the noise, right? It's how we know, for example, that the Earth is warming despite the fact that you can make a snowball in the middle of winter, right? But today I'm going to highlight an approach for informing coral reef conservation that's focused on identifying and learning from outliers, and specifically outliers that are doing well despite difficult conditions. Now, by their very nature, outliers deviate from our expectations and consequently can provide novel insights into confronting complex problems where conventional solutions have failed. And a great example of this comes from Save the Children in Vietnam, and they were working on the nexus of poverty and childhood malnutrition. And as you can imagine, these two topics are tightly coupled, right? Poorer children tend to be, on average, more malnourished than their wealthier counterparts. Well, what Save the Children did that I thought was very insightful was they identified poor children that were not malnourished. And they asked the mothers of those children what they were doing differently from other mothers in the village. And as it turns out, they were doing a couple of things. And among them, they were finding little crabs and shrimp in the rice paddies, and they were grinding it up and putting in their food. And they were also feeding their kids 3 times a day instead of the customary 2. Now, they weren't giving their kids more food. They couldn't afford to, right? But by breaking up the meals into smaller portions and spreading them throughout the day, the children were better able to absorb the nutrients. So Save the Children then had these mothers become sort of teachers to other mothers in the village, and then had these villages become living laboratories for other villages. They ended up cutting childhood malnutrition by 65% in target villages and reaching over 2.2 million households, right? This is an incredible human health outcome for a solution that was basically under everyone's nose the entire time, right? So this type of bright spots or positive deviance analysis has been used in fields such as business and health and human development to uncover local actions and governance systems that work in the context of widespread failure. And I think it holds much promise in informing conservation. So today, I'm going to highlight an approach that we use to examine reefs that, for all intents and purposes, should have been degraded, but weren't, and find out what we could learn about what they were doing differently. So here's my little roadmap of what I'm going to talk about today. The first part is I'm going to sort of define the expectations. It's going to be kind of like, finding the poor kids that weren't malnourished. We're going to talk about how we'll do that for reefs. Finding the reefs that are essentially punching above their weight, right? Then, a little spoiler alert, one of the key things that we found on here was that there was a really critical role of markets and the integration into markets, into the condition of coral reef ecosystems. And this is a finding I've had consistently through a number of research projects. And because of that, it's kind of become a focus of my research career. And so I want to kind of do a little side jolt into this. And it's going to get a little bit weird, particularly for the natural scientists in the room. But I think you'll enjoy it. But bear with me through the markets part of it. And then we're going to talk about locating bright spots. And then talk about what makes a bright spot bright. So on to defining expectations. So I started off by gathering about 40 scientists, and this included geographers like myself, political ecologists, economists, environmental scientists, ecologists, engineers, and statisticians. And we actually called ourselves the Social Ecological Research Frontiers Group, because the acronym was SURF, and we like to hold our meetings on surf breaks, and it seemed to have fit. So, but we felt like this was a topic that was too big for any one discipline to really manage. And this was something that really required this type of interdisciplinary approach. And I take interdisciplinarity very seriously. And although I didn't marry a social scientist, I didn't marry an ecologist, I did get married by one, and that's Tim McClanahan, who is probably the most prolific coral reef scientist in the world. He went online and became a reverend in some internet church and ended up marrying us. And all of my, most of my groomsmen were also ecologists as well. So this interdisciplinarity for me is very, very close and personal, right? But what we ended up doing, I ended up asking these 40 coral reef ecologists, or a number of coral reef ecologists, just to simply give me their life's work. And of course, if you've ever met a scientist, you know that that's a little bit like pulling teeth. But fortunately, my dad was a dentist, so I was able to do that extraction really well. But I think what actually really did help, though, was, in a sense, the fact that I was a social scientist made people a little bit more trusting. I wasn't going to be kind of in competition with the work that they were directly doing, and it was a novel approach that they hadn't done before. We ended up compiling about 7,000 surveys from 2,500 reef sites across 45 countries, states, and territories around the world. So at each site, we looked at a range of different sort of ecosystem conditions, right? And the first one and the main one that I'll talk about today is reef fish biomass, right? And that's simply, we measure it in weight per unit area, right? Kilograms per hectare or whatever. We also looked at the presence of top predators, right? So were there sharks or large groupers or jacks present? We looked at the parrotfish grazing, right? The amount of parrotfish grazing on there. And the thing you have to understand on coral reef ecosystems is that there's kind of a perpetual war between corals and algae, and the parrotfish kind of graze some of the algae and help sort of tip that balance a little bit towards coral reefs. In the absence of parrotfish, algae will often take over. So we looked at the sort of amount of parrotfish grazing. We looked at a metric of phylogenetic diversity and a metric of trait diversity as well. So it's two sort of biodiversity indicators. But mostly what I'll be talking about today is this fish biomass. And it was a kind of nice, to me, it's a kind of nice social ecological indicator, because the ecologists think of it as reflecting a broad selection of ecological functions. But for me, as a social scientist, it represents the availability of resources, right? It's the amount of fish that people can kill and eat, right? So this is a nice one for us both to work on. So here's the distribution of reef fish biomass in our study sites. And quite simply, the small red dots means there's no fish there, and the really big green dots mean there's lots of fish there, right? Now, of interest was that the median amount of fish on a reef was less than 400 kilograms per hectare. Now, that number in and of itself doesn't really mean anything unless you've got some sort of reference points for it. And in 2015, we published a paper which looked at a sort of a reference point for coral reef ecosystems. And unfished biomass, we concluded in this paper, was about, given average global conditions, was about 1,000 kilograms per hectare. And so using basic fishery science, maximum sustainable yields at about 50% of unfished biomass, right? So that would be about 500 kilograms per hectare. So, you know, what this is really getting at is that the majority of coral reefs in the world are fished, they're overfished, right? They're fished beyond sustainability. So we then wanted to predict the amount of fish on a reef based on the social and environmental conditions present. And so we used a Bayesian hierarchical model to quantify how reef fish biomass was related to a range of socioeconomic and environmental covariates, right? So the environmental conditions, for me, these are what I think of as my nuisance parameters. So there's things that I'm not at all interested in, but I know I need to control for. So these include things like productivity, depth, habitat, the way that they sampled it, right? So the area, the methods that they used, and how connected these reefs were to other reefs. We looked at a range of larger scale socioeconomic drivers. These included things like the Human Development Index, the population size of the country, a World Bank metric of governance quality called Voice and Accountability, which measures how people perceive their views are reflected by their government, the degree to which they feel that they've got freedom of association, a free press, and free speech, right? We looked at the amount of reef fish landings, and we looked at a metric of tourism arrivals relative to the national population. We also looked at a range of local socioeconomic conditions, right? Local scale sort of socioeconomic drivers. These include what type of management was in place, right? Were the reefs in a no-take marine reserve, and how well were these complied with? we looked at the level of human population growth in the surrounding area. We looked at an indicator of sort of local or subsistence pressure based on the size and accessibility of the reef to the nearest human settlement, and also looked at a metric of potential market interactions. Now, I'm going to go into this, obviously, this market one in just a moment. Now, what I'm not going to do is bore you guys with the sort of COEF plots or anything of that nature. If you guys are interested in the modeling, A, it's in the paper, or B, raise your hand afterwards and I can talk your ear off about that. But the key finding for me from this whole study was that the strongest predictor of reef fish biomass globally was our metric of potential market interactions. But not only was it the strongest predictor of reef fish biomass, it was also a predictor of the presence of top predators, parrotfish grazing, phylogenetic diversity, and trait diversity, right? So potential market interactions were the most consistent predictor of ecological conditions on coral reefs using a whole range of ecological metrics. Okay, so let's talk a little bit more about this. Now, the way we measured potential market interactions has an analogy with something that all of you experience every second of every day, unless you've been to space. And if you have been, this is probably the wrong lecture anyway. And that's gravity, right? And so if you guys remember from high school physics, right, the gravitational pull is the mass divided by the distance squared. Well, since the 1880s, economists and economic geographers have used this concept to measure and predict trade and migration flows between cities and countries. And it's often been called the most successful model in economics. So we developed a gravity metric that captures potential market interactions with reefs based on the size and accessibility of the nearest market. Now, this essentially measures the gravitational pull of markets on a reef. So my former, she was a master's student when she did this. She also did her PhD with me as well and is now a postdoc. Ava, she was able to actually compute this gravity metric for every single coral reef on the planet. This actually took up a lot of time on supercomputers. She's an engineer, so it took that kind of background. But one of the things we did to help people visualize that is add some vertical relief, right? So the areas with this sort of highest measure of market integration are those that are dark red and have these sort of high spiky peaks. And I think this helps us visualize how, for example, the nearest reefs to us here in Michigan are a really human-dominated seascape, right? But if we look at places like Australia and the South Pacific, we see a very different story there, right? The reefs are much more, much less dominated by these human impacts. So let's take a look at that relationship. So on the x-axis, we've got our sort of market gravity measure, ranging from low to high, and on the y, we've got fish biomass, ranging from basically no fish to lots of fish. And what we've got here, the sort of country-level averages, and the bubble size is the sample size per country because we had uneven sampling given the opportunistic nature of the sampling we did. But what we see is that there's about 4 times more fish, more fish on reefs that are far from markets than on reefs that are close to markets. And that's a major concern because markets are expanding profoundly, right? Last month, Indonesia announced that it's going to move its national capital to basically what's currently a very remote area, parts of the South China Sea, right? Uninhabited coral atolls are being populated. And probably of most concern is China's Belt and Road Initiative, which is set to be the largest infrastructure project in human history set to reorient global markets towards China. It's going to include massive port developments all throughout the South Pacific and Indian Oceans. So we know that markets have a profound impact on coral reef ecosystems, and there's a lot of analogs in terrestrial systems as well. Bill Lawrence has done a lot of the same sort of work in tropical forests. So what can we do to reduce or dampen the effect of markets? Well, this really requires understanding how markets can lead to exploitation. So it's really well established that changes in price and price variability can create incentives for exploitation. This is kind of just standard economics. And you know what? I buy it. I do. I think there's a lot of utility in this, but it's what we're just now learning that I think is much more interesting and where I think the potential for fundamental change lies. And there's an emerging body of research and behavioral economics and philosophy that's beginning to study how the very presence of markets changes the way that humans behave. And this can have big impacts on the environment. Let me explain. Much of human behavior is governed by social norms that determine what a society thinks is acceptable or not. And what we're finding is that the very presence of markets can crowd out or displace these social norms, often with unforeseen or perverse consequences. Now, let me give you an example of this that has absolutely nothing to do with the environment, but is one that many of you may be able to relate to, and one that has recently become very relevant in my life. So this is my baby boy, Ezra, and he started daycare last year. So many daycare facilities around the world have problems with parents being late picking up their kids. So a daycare center in Israel decided to do something about it, and they imposed fines on parents who were late picking up their kids. And as it turns out, the incidence of tardy pickups doubled. What happened? Well, prior to the fines, right, social norms made parents feel bad for picking up their kids late. But the introduction of the fines created the idea of compensation for the extra time, right? So the fines displaced this ethical obligation to be on time. And what happened was, 3 weeks later, when they reversed the fines, the incidence of tardy pickups persisted. Once eroded, these moral obligations were hard to revive. So we know that markets can affect 3 areas of human behavior that have direct relevance to conservation. And one of the most important ways that markets can crowd out pro-environmental behavior is by reducing people's propensity to engage in collective action or civic duty. And another example from Israel is that every year, students have one day where they go out and they collect money for charity. Behavioral economists got involved and they decided to place students into treatments. And they had one group that just went out and collected money, money for charity as they normally do. They had one group that got a 1% commission and one group that got a 10% commission. Well, what they found was the group that got nothing raised 55% more than the group that got the 1% commission. The group that got the 10% commission, however, did a little bit better than the group that got the 1%, but not good enough. So the title of the paper, they were a little bit cheeky. They said, well, if you're going to pay someone, pay them enough, right? But the idea here was that money crowded out the norms of civic duty. And in this case, it changed the character of the activity from a good deed to a job for pay. We also know that markets can crowd out people's willingness to harm others, right? They're sort of what economists would call third-party externalities. So people become more willing to inflict harm on other people. And markets can also crowd out, affect people's preferences for social equality or fairness. And critically, some of these, such as collective action, are actually the very foundations of community-based approaches to conservation, right? And we're finding that these can be undermined, potentially undermined by markets in ways that we're simply not paying attention to, right? And even worse, there's an entire branch of conservation called market-based instruments, right? And the very idea of them is to create new markets in the provision of environmental goods or in the avoidance of environmental harm. Now, how ironic, right, that these market-based conservation initiatives can actually be undermining, potentially be undermining, the very foundations of the conservation that it relies upon. So the question that we have to ask is, can we prevent the potential displacement of collective action, of equity, and intolerance to harming others, right? And I think part of that depends on understanding the mechanisms through which these work. And the one that I've already talked about is sort of replacing its intrinsic motivations with extrinsic motivations, right? But there's also this notion of diffusion of responsibility, right? When people are in a market setting, they feel like, well, why should I behave in this moral way? Because other people probably aren't going to do it, right? So it's what we call moral free riding. And lastly, there's this idea of framing. Now, framing is the notion that our choices are influenced by different wordings, by different settings, and by different situations. And people have suggested that simply having market framings can make people behave in ways that they think buyers or sellers should, right? They can become more cutthroat simply by the framing of this. Now, the critical question for me, the second step, would be then, can we create countermeasures that we could couple into conservation? Can we figure out ways to couple conservation with measures that foster intrinsic motivations or that reinforce individual responsibilities, right? So this has kind of become an area of interest in my research group, and we're now looking at how framing is affecting people's sort of cooperative disposition. And we're doing this by what's known as public good games, and they're sort of experimental economic games that are used to measure cooperation. And we're testing whether different framings, whether market framings or not, influence people's propensity to cooperate. And interestingly, what we found was framing did have a big impact, but not the way we expected. It ended up being different depending on the role. So buyers and sellers had different roles. So overall, the market framing had no effect, but there was a big effect if you broke it down by roles. It was just that those two roles canceled each other out. Okay, so let's move on to sort of the locating the bright spots part of that. So we had our model from before, and this was kind of the basis for our expectations. So we then wanted to find places that were doing better than expected given the socioeconomic and environmental conditions they were exposed to, right? We were essentially looking for the reefs that were punching above their weight. In nerdish, we would call this deviations after having accounted for a covariates, right? So we used 2 standard deviations as a conservative definition of an outlier, right? Remember from basic statistics, 1 standard deviations were about 2/3 of the data lie, and 2 standard deviations were about 95% of the data lie. So we were looking for bright spots that were really, quite extreme outliers there. But we found that bright spots tended to be concentrated in the Pacific, right? And they occurred in both remote, but also in populated places, including Taboeron, Solomon Islands, Papua New Guinea, and parts of Indonesia. Now, one of the things I really want to emphasize is that this is a relative, not an absolute metric, and a number of the ecologists on the team had trouble getting their heads around this. They felt like the bright spots had to be the places that nobody'd been yet, or that were least affected, that had the best absolute conditions. And what we're really getting at here is where are the places that are punching above their weight, that are doing better than you'd expect, given the conditions that they were exposed to. And some of these actually had biomass values below the global mean, right? Well, we also looked at dark spots. We looked at places that were doing worse than expected, given the conditions they were exposed to. Right? And this was interesting because, these essentially represent the paths to avoid. These are the things you don't want to do. And we found that these dark spots really didn't discriminate. They occurred in wealthy countries, in middle-income countries, and in poor countries. They were quite ubiquitous. Now, one of the things I kind of like about this approach is that, to me, it sort of challenges some key expectations. The Caribbean's often considered the basket case of the world's coral reefs, and with good reason. Things are not going well there. But we only found a couple of dark spots there, right? What we're finding is, given the conditions that the reefs there are exposed to, they're behaving pretty much exactly as we'd expect, right? And that has a lot of implications for the sort of growth trajectory of other places. Now, incidentally, one of those dark spots is exactly where I spent 2 years as a Peace Corps volunteer. It was literally in the marine park that I was assigned to as a Peace Corps volunteer. So I know that I kind of understand why it's a bit of a basket case, but I also hope that it was nothing that I did while I was there as a Peace Corps volunteer. Another bit that I thought challenged people's expectations again was, the Northwest Hawaiian Islands. Not all of the reefs there, but some of the reefs there came up as dark spots. Now, these are places that are like 1,000 miles away from the nearest human, right? These are really, really remote reefs. And there's actually a lot of fish on them, right? But given the fact that they're really remote and they're in a wealthy country that's got good governance, they actually, they performed worse than expected, given those conditions. And, my favorite is probably the Great Barrier Reef. it's often considered the best managed reef in the world. And what we found was, well, it was nothing special in that regards. It was performing exactly as we'd expect, right? Given the fact that it's in a wealthy country with solid governance that has, most of the Great Barrier Reef is in areas that aren't heavily populated, and the reefs are, 80 kilometers off of shore. So we kind of found that given the conditions there, the Great Barrier Reef wasn't great, it was the average barrier reef. All right, so what makes a bright spot bright? So previous work on bright spots has identified three broad areas or three types of conditions that might lead to bright spots. These include environmental conditions, social and institutional conditions, and technological conditions. So we surveyed local experts at 15 bright spots, at the 35 dark spots, and at 14 places that kind of performed right in the middle, right exactly as we kind of expect them to. So in terms of environmental conditions, we found that bright spots tended to have deep water refuges nearby, right? So they tended to be near areas where fish could presumably get some, go down and get some depth refuge from fishing pressure. However, we found that dark spots tended to have been exposed to a recent, like within the last 5 years, environmental shock. This could have included a cyclone or a coral bleaching event. And I think, that finding is definitely of concern given the global trajectory of our carbon emissions and the fact that, the footprint of coral bleaching episodes is increasing, right? There are places that we used to think were refuges that are getting bleached every time there's a new event, and the return window between bleaching events is decreasing, right? There's less time to recover between events. We also found that dark spots tended to have different technological use. They tended to use more intensive netting techniques that could damage the coral habitat architecture, and they also tended to use freezers, which allowed communities to stockpile fish to store and then send to markets. Well, interestingly, we found that in terms of the social and institutional conditions, bright spots tended to have higher levels of dependence on fisheries. Now, this seems slightly counterintuitive, right? People might think, well, shouldn't bright spots have lower dependence and people wouldn't use them as much? But decades of research in common property studies have found that people are more willing to invest in creative solutions when their livelihoods depend on it. We also found that there were higher levels of engagement by local people in coral reef management and bright spots. And interestingly to me, that there were critical sort of cultural connections or cultural practices at play in the bright spots. They were more likely to have these sort of cultural practices. And these included things like customary marine tenure, which are property rights systems that allow communities to exclude outsiders. They also included sorts of taboos, right, where communities would have cultural practices, taboos that would prevent people from fishing at certain times. So what I'd like to do now is take a little bit of a deep dive. I want to highlight some of these key conditions by talking about one bright spot in particular. Now, serendipitously, of all the places that we studied and of the places that came out as a bright spot, one of the bright spots happened to be a place that I'd started working in 2001, and we've been collecting data periodically over sort of 16 years. So we were kind of really well placed to then do a really sort of deep dive into what makes at least this bright spot bright. So that place is in Papua New Guinea, of course, on a place called Karkar Island. It's about 25 kilometers off the provincial capital of Madang. Now, we worked in two communities there, Malouk and Wadao. Now, as I mentioned, we've been collecting social and ecological data there since 2001. Now, an interesting thing, the interesting cultural practice that they engage in here is a rotational closure system, and it's akin to fallow agriculture, right, where they close off a reef for a certain amount of time, and then later they open it up, and they might close another patch of reef, and then they might open it up, right? And these closures occur for for about 2 to 7 years at a time. There's no set time at which they do it. It's not on a calendar as you and I would think about it. It's based on different social and ecological baselines. But this practice is engaged in by both communities that we studied, which is, well, let's call it an interesting design. It's a little bit annoying when your experimental site becomes your control site and your control site becomes your experimental site, but we worked with it. We made it happen. So let me describe what we did do. And so these dots are the places where the ecologists counted fish and things. And so in 2001, when we went, the reefs in front of Malouk were closed to fishing, right? Those are in red. So that area, you couldn't go fishing on those reefs. In 2009, when we went back, those reefs were still closed to fishing. You still couldn't go fishing there. In 2012, the reefs in front of Malouk were now open. Everyone was fishing there. But the reefs in front of Wadao were now closed. You couldn't go fishing there. 2016, we went back, and the reefs in front of Malouk were now open, but the reefs in front of Wadao were closed. And in 2017, when we went back, all of the reefs were open. Right? So I won't get too much into the details there, but when we compared biomass of fish on open versus closed reefs, we found there was more than double the amount of fish when they closed the reefs compared to when it was open. Right? So this is a key finding. It really did work to increase the amount of fish on a reef. But that's not why they did it. They did it to change fish behavior. They say that if you fish a reef too often, the fish become scared, and they stay really far away, and that makes it difficult to go spearfishing and to go net fishing. So the main goal of this practice isn't to increase the number of fish on the reef, it's actually to change fish behavior in ways that make it easier to kill fish. So we actually studied this. We got, I ended up getting a PhD student he called it frightening fish for science. And he would measure the flight initiation distance. He would find a fish, and he would swim towards that fish. And as soon as that fish would flee, he would drop a stone there and then measure the distance between that. And so we were able to test the average distance that fish would flee in closed versus open areas. So, and the interesting thing that we did in this part of the study here was the closures were adaptive, right? So in some cases, the reefs were closed, and then those same reefs were open. And then the other community, the reefs that were open, were then closed. So we were able to see the difference on the same reefs rather than just doing an inside-outside comparison. So what we looked at, what we found was in Malouk, when it went from closed to open, the flight initiation distance increased from 8 to 11.5 feet. And in Wadao, when they closed the reef, it went from 13 to 9 feet. Now, interesting, okay, there's two things that I think are important here. First is, does this behavior influence our UVC results? That's the kind of first thing that people say, oh, maybe the abundance isn't really abundance, it's just that. Well, actually, the people that are doing the dive surveys are looking further ahead than this. They look on average sort of 9 to 10 meters forward. So all of the changes that we're seeing here are within the area that they're sampling anyway. So they're counted the fish before the fish would flee. So the ecologists on the team argue that this doesn't bias the UVC results. But the second thing that's really cool is, okay, so fish were flightier when fishing was allowed, but the thing that's really cool is the average spearfishing distance was about 10 feet. That was the average distance at which the fishermen estimated they could kill a fish. Now, that didn't mean they never caught a fish when it was open to fishing, right? Some fish were less wary than others, some were more, and some fishermen are better shots, and sometimes you get a lucky shot in. But on average, when reefs were open, fish tended to stay outside of the range of spearfishing. And when reefs were closed, they tended to stay within the range of spearfishing. Now, what that means, though, is when you go from a closed reef to an open reef, boy, you can clean up. And they did, right? And they would have these massive harvests. This is part of the harvest by one of the 3 clans. So it was about probably 6 times this amount of fish there. And they would have a big ceremony. They would have a big sort of feast after this was, after the reef was opened. And an important thing to note is that they would invite neighboring villages over. Now, in Melanesia, which Papua New Guinea is part of Melanesia, your wealth is not judged by what you own. Your wealth is judged by what you give away. So the social prestige in being able to gift fish to other communities was huge. That was worth a lot. That was a really kind of important part of what they were doing. So lastly, we sort of looked at how people perceived this affected their livelihoods. How did people think that these closures, were they beneficial or were they detrimental to people's livelihoods? So we found that in 2009, we found that about 65% of people said that these closures, this taboo system, was positive for their livelihood. And the overwhelming majority of those thought it was very positive, right? Not even just a little bit. It was really good. Less than 10% thought it was negative, and about a quarter of the people thought it was neutral. It wasn't bad or good. It didn't really affect them in either way. Now remember, that's when the reefs were closed. When we went back a couple of years later, and the reefs were open in Malouk, the negative perceptions went away, right? So that 10% of people that used to have a negative perception, we didn't encounter a single person that said they were bad for them. But in Wadao, when the reef was closed, when the closure was active, a similar proportion, maybe 10, 15% of people thought it was negative for their livelihoods. When we went back in 2016, again, the negative perceptions in Malouk were there, but there were no negative perceptions in Wadao. What the heck is going on? Well, we think this can be partially explained by what's referred to as the peak-end rule, or peak-end heuristic. And this is also called duration neglect. And this was first discovered by Danny Kahneman, right? And he's he won the Nobel Prize in economics, even though he's a psychologist. And what he talked about was there being a distinction between what people experience and what they remember. And people often only remember the peak of an experience and the end of an experience, right? And this has been things for meals and for pain. And when the end is pleasant, they have fonder memories of the entire thing. Now, the example that this comes from is a uncomfortable topic, colonoscopies. What Kahneman did is he was working with doctors to improve revisitation rates. After people have a colonoscopy, they tend to never want to see that doctor again. And they don't come back for follow-up visits. So what Kahneman suggested was that they increase the total amount of pain that patients experience, which sounds insane. But what he suggested was, at the end of the procedure, just leave the scope inside for another sort of 20 or 30 seconds. Don't move it. And apparently that is uncomfortable but not as painful, right? And what happened was the patients who had more pain overall, right, the whole duration was longer, they had the same procedure as the ones that didn't. It was the exact same thing, but longer. So the patients that had more pain, but the end wasn't as bad, rated the whole thing as better and went back for more follow-up visits. They were much more likely to get better medical care. Now, this actually introduces kind of a quandary when your thing is do no harm, right? When doctors are supposed to do no harm, but actually have to inflict more pain to get better medical outcomes. So anyway, but I guess the point is what we're seeing here, we think may be an application of this peak-end heuristic. All right, so what are some of the take-home messages from this? One, I think we need to embrace a broader range of potential policy levers. Things like markets. These were the strongest drivers of change we saw in coral reefs globally. And I think there may be some opportunities to sort of dampen the effect of markets. I mean, I don't think we can realistically get rid of markets. So, I mean, we're not going to raise cities. We're not going to, make every port like Aleppo or something, right? So, but we need to think about ways where we can dampen the effects of markets. And we may be able to do this by coupling conservation with the types of countermeasures I talked about. Well, there's also the potential to learn from places that have effectively confronted these strong drivers of change. Now, I would argue that investments in strengthening fisheries governance, including ownership and involvement, right, and investing in social capital, could facilitate innovative conservation actions that can help communities defy expectations of global reef degradation. But alternatively, the more typical efforts done by development agencies to provide capture and storage infrastructure, and particularly in cases where there's environmental shocks or where local governance participation is weak, right? This may lead to situations that reinforce resource degradation beyond our expectations. And lastly, I think it's really important to work together, to have these sort of interdisciplinary collaborations with engineers and ecologists and social scientists, and to think outside the box. You know, how can we harness things like the peak end rule better in conservation? How can we harness a whole range of these heuristic biases and cognitive biases that people have? How can we harness these for conservation? These get harnessed with us every single day for marketing. Everything you've bought has been sort of placed in a certain way, brought to your attention in a certain way. The marketers use these sort of cognitive biases constantly with us. But as conservation scientists, we tend to not use these tools. So thanks very much to my family, to my surf team, my research group, who's awesome, and Jake for inviting me. Thanks so much. And I think we've got plenty of time for some short speeches designed to disguise as questions. Thanks. Yeah.
Okay, so could you expand more in how you measure the effect of markets? Because I know that there are several things that you can measure there, and I know that you have it for all the different reefs. So could you expand on that?
Right, so what we simply did is we measured what I would call the potential market interactions, right? We didn't measure the actual connections there, but we measured that sort of, you know, the potential gravitational pull that a market would have on a reef. So that was the size of the nearest port or provincial capital divided by how far away that was. Now, one of the things that we did was rather than use linear distance, so how far was it as the crow flies, right? We actually created this metric of travel time, right? And the way that we did this is we used global sort of land cover data. And believe it or not, people have actually timed how long it takes to go through a swamp. And they've timed how long it takes to go through a savanna, and they've timed how long it takes to go through all these different sort of habitat types. So there's actually a travel time that you can get for each cell of land cover. So what we were able to do was measure the least cost route between the reef and the port or provincial capital that we were measuring. And so this was essentially, if you think about it, it's kind of like your Google Maps, but so it kind of just measures the quickest route to get there. And so we used the population of that market divided by the travel time squared. And we, you know, this gravity metric, you can use a whole range of exponents. The standard one is sort of is divided by distance squared. We did do model selection for, you know, not squared, squared, cubed, a whole range of them, and we found that squared would perform the best. Yeah, but
more about like the physical distance and population.
Yeah.
More than like the intensity of the market in terms of catching the fish.
Right. So, yeah. So as a social scientist, you know, this metric of potential market interactions is profoundly disappointing, right? So when I think of market structure, I think about sort of value chains and how they're oriented. I think about, you know, buyers and sellers and middlemen relationship. Well, none of that is available at a global scale, right? So, you know, one of the things I often feel is that global analyses are an exercise in global disappointment. There's so many things I'm disappointed in this paper in, and that's of course one of them, you know, because there's so many things that we know we would love to have more detailed things at. But the neat thing is, I mean, this to me is like a rough as guts measure. It's like as coarse as you could get, yet it still is the best predictor of the amount of fish on a reef globally, and also the predictor of whether there's predators there, whether there's herbivores there, whether there's, you know, the level of phylogenetic diversity and the trait diversity. So even missing all of the nuance that social scientists, I mean, yeah, this drives social scientists crazy, right? Because it's so coarse. But even being that coarse, it's the strongest predictor of the condition of coral reefs. So maybe I should turn this into a pitch. So with $20 million, I could get a better measure. And, that's probably what I need to do for my next proposal. Thanks. Yeah.
I have two questions.
Yep.
Firstly, about the flight behavior of the fishes.
Yep.
Is that heritable or it is plastic and reversible?
Well, I think it's totally plastic and reversible because what we see is when we do this over time, and so when we open a reef, if a reef's closed to fishing and then we open it, the flight initiation distance of the fish change. Right? And vice versa, if we have a reef that's closed to fishing and then we open it, I don't know if I said that one first. Anyway, but we see it go backwards in both directions. Now, to be fair, we haven't tagged individual fish and followed them as they do that. So, I guess you could argue that it remains unanswered, but our guess is that it's totally plastic. But, let me just add one more thing to that. But it does change by species. Right, so different species have different flight distances, and what I didn't tell you was that was the model predicted one because we had different species, so we controlled for species in what you saw. So that was the model predicted average, accounting for species and habitat and all the other things we included in the model. That was kind of something I just glossed over.
The other question is, I suppose people in different places may eat different kinds of fishes. Some may eat whatever thing they can catch. Some may only eat certain species. So which kind have a greater impact on the coral reef?
Yeah, so it is true there are cultural preferences for different fish. But many coral reef fisheries are in poor developing countries where, people do have preferences, but they also don't have the luxury of, in many cases, adhering to those preferences. Now, even in Papua New Guinea, certain families have taboos. So certain families will have a taboo where they can't have a certain type of fish, right? But that tends not to be through the population. That tends to be a family-specific thing that gets inherited typically from the matrilineal side there, right? So we do see these sort of micro-preferences. I would, and certainly some countries don't target certain things. So for example, in Australia, we tend not to target parrotfish. It's just not on our menu there. Where they're delicious, but in many parts of the world they do target parrotfish. So one of the things you're right in a sense, could cultural preferences play an impact in how many fish there are? I don't really think so. I don't think it's a huge impact. I think most coral reef fisheries target a really wide range of fish. We counted 169 different species targeted just by spear guns in Papua New Guinea alone. So people really are targeting a very broad range. It's a multi-species fishery on coral reefs. So yeah, I mean, it's a complicated answer, but it's a multi-species fishery in general. Yeah. Oh, sorry, in the back. So there are multiple social dynamics, and one is exactly like you said, fishing is getting hard. There isn't an exact metric, like they don't measure CPUE and then say once it goes below 4.7 kilograms per hour or whatever it is that we do. So it's more of things are getting harder. So that's one thing, but there may also be a forward-looking, there may be an event such as a death in the village. So sometimes if there's a death in the village from someone prestigious, like a clan chief, they'll close off all the reefs and then have a ceremony at the end of that, right? And then, and the other thing that they do is, so fishing's hard, there's a ceremony, or there's something that they want to prepare for. So maybe there's going to be they want to do something special for the Christmas feast this year, so they'll plan that out 12 months or 18 months in advance and close it off for that. So those are the kind of three main reasons that they do that. Yeah.
Unless we project forward, say, 30 years, when the ocean temperature has increased significantly, how is the
The outlook's grim, is the bottom line. I mean, so, one of the things I didn't present here was that we actually tracked coral cover over time in this site, and it's actually increasing, which is a very weird result. It's up at sort of an average of 60%, but some of the reefs have basically 100% coral cover, which is kind of unheard of. You think about the Great Barrier Reef being pretty good, it's about 20% probably. We just published a paper this year in Nature, Ecology, and Evolution, and I think the average was probably 24% coral cover globally. And so what we're seeing on car is that's increased to about 60% is the mean there. But it's only one bleaching event away from zero, right? That's basically all it takes. And with the increasing footprint of coral bleaching, things look grim for coral reefs. And I think they're kind of the canary in the coal mine for the world's oceans. Now, some coral reef scientists would actually argue that everything I'm doing is a waste of time and that I should really be just focused on, particularly as a social scientist, how can we reduce carbon emissions? And on one level, they're right? So if we don't take care of global warming, reefs as we know them are done. Right? That doesn't mean there won't be some fish there, and that doesn't mean there won't be some corals there, but the magnificence that we know as coral reefs will no longer be with us. But my counterpoint to that is that's going to take a little bit of time. And if we take our eyes off the ball of nutrient loading from land-based sources of pollution and sedimentation and overfishing, once we sort out global warming, there'll be nothing left anyway, right? So I'm a big advocate of a multi-pronged approach to coral reef conservation, that I don't tend to exclude much except things that simply don't scale, like the Australian government's investment in little fans to cool the Great Barrier Reef. I would argue that that's a complete waste of time and a diversion by fossil fuel interests, but that's maybe a different story. But I guess my general thing is I'm a everything's on the table advocate for coral reef conservation. That includes certainly addressing carbon emissions, but at the same time also dealing with coral reef fisheries, particularly where people's livelihoods so profoundly depend on them. Yeah. Oh, yeah.
To briefly follow up on that. The bright spots, which I love that concept, the sites that were doing well, those had no sort of perturbation, common perturbation. And so
they were less likely to have had one. I think they might have had, so a few of them might have had it, but they were less likely to have had climate perturbations or cyclone. Yeah.
So is that, like in the sort of more global model, is that signal, how does that weigh in relative to the other parameters? Is the reason why they're bright spots is because of that, or how?
No, so we didn't do it that way. So what we did, let me just explain this. So we had our model that predicted reef fish biomass on reef, and then we looked at deviations from those. And then what we did is we zoomed in with much more detailed information than we'd be able to get for each coral reef, right? And so that's where we were able to look at sort of levels of participation and like cultural practices. Like that information isn't available on every coral reef. And also the things like the bleaching. So we kind of did that only for the subset of reefs that were bright spots, dark spots, or average spots. So just to be clear, things like coral bleaching in the last 5 years wasn't in our initial model, but our initial model did include a metric of sort of sea surface temperature anomalies.
Even still within those, they just were less likely to have.
Yeah, bright spots were less likely to have been exposed to those. And that's why I said it's kind of a concerning finding, because the global footprint of coral bleaching is increasing and the return time between events is reducing, right? The return time between the coral bleaching event on the Great Barrier Reef of 2016 and 2017 was 1 year, right? And so, if that was 5 years minimum on that, we're not seeing that, so, yeah. Great, any last questions?
All right, let's give Josh a hand.
Thanks so much, guys.